Circular motion. What is circular motion? Circular motion is a kind of motion wherein the direction of motion is always changing, since it is moving in a circular path, unlike objects moving in straight lines. The direction of motion is always changing, because the force of the object moving in circle is directed towards the center known as centripetal force. Centripetal force gives the circular motion of an object. Without it, an object will not move in circular path. The centripetal force gives centripetal acceleration on the object which also towards the center. Where is the centripetal force? The centripetal force is the man's right hand. Without him moving the string will not move in circular direction. In a circular motion, without a string, the object will not move in circular path. In order to keep the object moving in circle, you must hold the string firmly. In the picture, the dot at the center is your centripetal force. The yellow line is the string, while the green circle is the object attached to the string. If you cut the string while the object is moving in circle, what will happen? If you cut the string while the object is moving in a circle, the object will not move in circle anymore. The object will fly in straight line tangent to curve. Tangent is a straight line or plane that touches a curve or surface at a point, but if extended, does not cross at that point. If the string is suddenly cut when it is moving in motion, it will fly away in the tangent direction. The green arrow is the tangent. It is the direction where the object will fly. Frequency of revolution. It is defined as the number of circular revolution in a given time interval. It is the number of how many times an object move around in circle, in 1 second. The formula for frequency of revolution is F is equal to n divided by t, wherein n is the number of revolution, t is the time given to complete number of revolutions in seconds. The unit is Hertz from Heinrich Rudolf Hertz. Example problem. Problem number 1. A man holding a string, with a ball tied at the end, set it in circular motion. In 10 seconds, the string completed 30 revolutions. What is the frequency of the revolution? In solving a problem, do not forget to write the given formula and solution. First, identify the given. If you read the problem once again, the givens are 10 seconds, which is the time, and 30 revolutions, which is your n. The missing or what is needed to solve is the frequency of revolution. Therefore the formula we will use is F is equal to n divided by time. In solution, substitute the values in the formula. F is equal to 30, which is your n, divided by 10 seconds, which is the time. The answer would be 3 per seconds or 3 Hertz. Don't forget to write the unit always. Tangential speed or tangential velocity is the linear speed of something moving along the circular path. A point outside the edge of a merry-go-round or turntable travels greater distance in one complete rotation than a point nearer the center. Remember, if you cut the string while it is moving in circle, it will fly away. Tangential speed is the speed of the object which flew away. The formula for tangential speed is V is equal to F 2 pi r, where F is the frequency of revolution in Hertz, pi is 3.14, r is the radius in meter, and V is the tangential speed with the unit meter per second. Sample problem. We will include problem 1, which we solved a while ago. In problem number 1, we are asked to find the frequency of revolution, and our answer is 3 Hertz. In problem number 2, if the man released the string while it is in motion, considering that the string length is 0.30 meter, what would be its speed? First, identify the given. The givens are 3 Hertz, which is your frequency of revolution in problem 1. The length of the string, which is 0.30 meter, is your radius. The missing or what is asked to solve is the speed, which is v. Since the speed is missing, we will use the formula for speed. The formula is v is equal to F 2 pi r. In solution, substitute the given values to formula. V is equal to 3 Hertz, which is your frequency, times 2, times 3.14, which is the pi, times 0.30 meter, which is your radius. Multiply 3, 2, 3.14, 0.30. The answer would be 5.652 meter per second or 6 meter per second. Another example problem. Calculate the frequency of revolution and tangential speed of a 2-meter string, moving in circular motion, which completed 50 revolutions in 16 seconds. First, identify the given. If you read the problem once again, you are asked to calculate frequency of revolution and tangential speed. Therefore, you will solve for f and v. 2-meter string is your radius. 50 revolution is your n. And 16 seconds is your time. In formula, since you are asked to calculate for frequency of revolution and tangential speed, you will use two formulas. First is for the frequency of revolution. F is equal to n divided by time. And for the tangential speed, v is equal to f(2 pi r). In solution, distribute the given values in formula. First you must solve first the f, the frequency of revolution, because you can't solve tangential speed without frequency of revolution. F is equal to 50, which is your n, divided by 16 seconds, which is your time. The answer would be 3.125 per second or 3.125 Hz. Now that you have your frequency of revolution, you can solve the tangential speed. V is equal to 3.125 Hz, which is your f, times 2, times 3.14, which is the pi, times 2 meter, which is the radius. Multiply 3.125 to 3.142. The answer would be, V is equal to 39.25 meter per second. Another example. A string 4 meters long was set in motion. In 1 minute, it completed 50 revolutions. If the string was released while it is in motion, what would be its tangential speed? First, identify the given. A string 4 meters long is your radius. 1 minute is your time. Convert 1 minute to seconds. Since our unit for time is seconds, 1 minute is equal to 60 seconds. 50 revolution is your n. The missing or what is asked to solve is tangential speed or v. In formula, since you were asked to solve for v, use the formula for tangential speed. V is equal to f(2 pi r). But remember, you cannot solve tangential speed without frequency of revolution. Therefore you need to solve for it as well. F is equal to n divided by time. In solution, distribute the given in formulas. First solve for f. F is equal to 50, which is your n, divided by 60 seconds, which is your time. The answer would be 0.83 per second or 0.83 Hz. Now that you have your frequency of revolution, you can solve for tangential speed. V is equal to 0.83 Hz times 2 times 3.14 times 4 meters. The answer would be 20.8496 meter per second or 21 meter per second.